Okay guys, welcome again to another series of videos. Today we are having a nice challenge which reads open bracket x to the power of 3 close bracket or to the power of log 4 to base 2 plus 4 to the power of log x to base 2 equals 10. So we are looking for the possible value of x in this challenge. So we are looking for the value of x, and at the end of this class we are going to plug the value of x into this question and see whether it's going to give us 10. So if you are new here, please subscribe, and by the time you subscribe, don't forget to turn on the notification button so that you get notified anytime I drop videos on mathematics, because in this channel I always solve problems on mathematics such as calculus, algebra, Olympiad mathematics, and many more. So let's see how we can solve this nice challenge. So we can simply say solution. You can say solution because we are having x to the power of 3 or to log 4 to base 2 plus 4 to the power of log x to base 2 is equals to 10. So instead of us writing the whole of this again, we'll simply go further solving it. Recall from indices, because in this class I'm going to apply some principle of indices and other basic mathematical rules. So let's solve. Recall from your indices, if we are having a to the power of m or to the power of n is also equals to a to the power of m times n. So if I'm applying this rule here, I can simply rewrite the whole of this to the x to the power of 3 times log 4 to base 2 plus 4 to the power of log of x to base 2 is equals to 10. Nothing changes, it still remains the same by me applying this rule from your indices. Okay, since we've gotten this, what are we simply going to do? Okay, from our indices again, we can still rewrite a to the power of m times n is also equals to a to the power of m, open bracket, close bracket, or to the power of what? Of n. So if we should succumb to this rule, putting it here, we can say x to log of 4 to base 2 or to the power of 3 plus 4 log x to base 2 is equals to 10. So this rule, I'm applying it here. That is the reason why we are having the whole of this. Okay, since we've gotten this, from your indices, from your rules of logarithm, if you are having x to x to log a is also equals to a to log x. If you're having x to the power of log a is also equals to a to the power of log x. So in the place of this, not log x, we are having to the power of log x to base 2. Yes, this is what we are having. That's what we are having there. Okay, if you apply this rule here, we can simply rewrite this again. How can we do that? We can say, okay, let's take x log of 4 to base 2 is also equals to 4 log x to base 2. X to the power of log 4 to base 2 is also equals to 4 log x to base 2. So in the place of x, we can put this. So in place of this, we can put this. So here we can write this. So writing this, we're having 4 log of what? Of x to base 2 or to the power of what? Of 3. Or to the power of 3 plus, we are having 4 log x to 2 is equals to 10. Okay, since we've gotten this, let's p equal 4 to the power of log x to base 2. 4 to the power of log x to base 2. So wherever we see 4 to the power of log x to base 2, we are putting p there. Okay, if we should do that, we are going to have p to the power of 3, or instead of us writing it, we are having p to the power of 3 plus p equals to 10. So we are now having a polynomial equation, p to the power of 3 plus p equals to 10. So we can write this again to be p to the power of 3 plus p minus 10 is equals to 0. We are having p to the power of 3 plus p is equals to 10. And so if we write this again, we are having p to the power of 3 plus p minus 10 equals to 0. So now we are now having a polynomial equation. So how can we solve this? Recall, we are not looking for p, but for us to look for x, we have to look for p first, then move further to look for x. Now we are now having a polynomial equation. Let's move further to look for the value of p, then look for the value of x. Okay, since we've gotten p to the power of 3 plus p minus 10 is equals to 0, for us to solve a polynomial equation, something like this, because this thing is, can I say complex? No. Okay, this is a polynomial equation. How then can we solve it? The first thing we are going to do, we are going to think of a number. If we plug the number into, we are going to think of a number. If we plug the number into this equation, we are going to have 0. So what are we going to do? What then is that number? We can say let p equals to 1. If p equals to 1, if we put p here, p equals to 1, then we'll put 1 here. 1 to the power of 3 is going to give us 1. And 1 plus 1 is going to give us 2. 2 minus 10 is going to give us minus 8. It's not equals to what? It's not equals to 0. So we reject this one. We can what? We can reject it. We can reject this one. So the next thing we are going to do, this is reject. So we pick p is equals to 1, and p is equals to 1 does not work, and we reject it. We are going to pick the negative 1 to see whether it's going to work. If we put the negative 1 here, negative 1 to the power of 3 is going to give us negative 1, and negative 1 minus 1 is going to give us what? A negative 2, which is minus 2. Minus 2 minus 10 is going to give us what? It's going to give us minus 12, which is not equals to 0. So p equals to minus 1. We are also rejecting it. We are also rejecting it because it's not giving us equals to 0. So let's move further a little bit. So let's take p equals to 2. When p is equals to 2, if we should plug p equals to 2 here, 2 to the power of 3 is going to give us 8. 8 plus 2 is going to give us 10. 10 minus 10 is going to give us 0. So p is equals to 2, what? We accept it. P is equals to 2 is going to what? Is going to work. So the first value of p here is 2. The first value of p here is 2. So my p is equals to 2. So how then can we look for the remaining value of p? We can look for the remaining value of p because we are having p to the power of 3. In other words, we are going to have 3 values for p. So we can look for the remaining value of p by dividing the whole of this with this. So we can rewrite p is equals to 2 to the p minus 2 equals to 0. Because we said p is equals to 2, so if we should bring it here, we are now having p minus 2 is equals to 0. So we are now going to use the whole of this to divide this by the long division method. So let's see how we can do that. Okay, now let's apply the long division method. The long division method says we are just going to use the alphabetical number to divide the alphabet. Then multiply this with what to divide, then multiply this with what to divide also. So let's apply the long division method. If we divide p to the power of 3 with p, we are going to have p squared. So multiply this with this, we are going to have p to the power of p times p squared is going to give us p to the power of 3 or p cubed. Then minus 2 times p squared is going to give us minus 2p squared. We want to eliminate p to the power of 3 or p cubed. How can we eliminate it? We are having a positive here, we are having a positive here. For them to eliminate, one must have a negative. One must have a negative since both of them are having positive for them to eliminate themselves. So we are going to multiply both sides with a negative sign. And if we should do that, it's going to affect this one, it's going to affect this one. So we are going to draw down an horizontal line. This times this is going to give us a negative p to the power of 3 or a negative p cubed, and positive p cubed minus negative p cubed is going to give us what? It's going to give us 0. So we are having the whole of 0 here. Then this times this is going to give us a positive 2p squared. And if we should add up, we are going to have 2p squared plus p minus 10. This is what we are now having. So if we use this to divide this, we are going to have plus 2p plus 2p. Then this one to multiply this one again, we are going to have 2p squared. Then this one to multiply this one, we are going to have minus 4p minus 4p. Putting down the bracket again, sorry, horizontal line. We are having 2p squared minus 4p. This is positive, this is positive. How can we eliminate two of them? By putting a negative sign, right? Multiplying this with a negative sign. If we multiply this, we are going to turn this one is going to turn to a positive. So this times this is going to give us a negative, and 2p squared minus 2p squared is going to give us 0, right? Then p plus p, this one is going to turn to positive. P plus 4p is going to give us what? 5p. So we are having 5p. Then put this one down, minus 10. So what are we simply going to do again? We are going to use this p to divide this. We are going to have a positive 5. Positive 5. So this times this is going to give us what? 5p. Then this times this is going to give us minus what? Minus 10. This is a positive, this is a positive. How can we eliminate two of them? We can eliminate two of them by multiplying both sides again with a negative sign. So this one is going to turn to a negative sign, right? This one is going to turn to a positive sign by multiplying it with a negative sign. So 5p minus 5p is going to give us what? 0. We are going to have 0 minus 10. So this one is going to turn to a positive sign. Minus 10 plus 10 is going to give us what? Plus what? 0. So we are not having any remainder. So this is now our new equation. So we can write the whole of this here. So this our new equation becomes p squared plus 2p plus 5. So we are now having p squared plus 2p plus 5. How can we look for the value of p here now? We can solve this, and now we are now having a quadratic equation. We can solve this either using the factorization method, or using the completing the square method, or using what we call the formula method. But before we move further, we want to try whether this is a real solution or not. If it is a real solution, we are going to accept it. But if it is not a real solution, we are going to reject it. How then can we look for it? How then can we test this is a real solution? We can say delta is equals to b squared minus 4ac. This is the method to test whether it is a real solution or not a real solution. So we can say your b is equals to 2, your a is equals to 1, then your c is equals to 5. So if we say delta is equals to what? B squared. So your b squared is what? 4. 2 to the power of 2 is going to give us 4 minus 4. What is your a? Your a is 1 times what is your c? Your c is 5. We are having 5 here. Times what? Times 5. So I'm going to say delta is equals to 4 minus 4 times 1 is going to give us 4. 4 times 5 is going to give us 20. So we are having 20 here. Delta is equals to 4 minus 20 is going to give us minus 16. Minus 16. So this, since it's carrying a negative sign, this is not a real solution. So we are going to reject it. We are going to reject it because having this is going to lead us to a complex number, a complex values. So we don't want to work with complex values. So we reject it. Then work with the first value of p, which says p is equals to 2. If p is not equals to 2, if p is equals to 2, what then is x? What then is x? Recall we said we are taking 4 we are taking p equals to x to the power of 4 log of 4 to base 2. We said this is our p. P is equals to x to the power of 4 log s to base 2. Or rather, we say p is equals to 4 to the power of log of x to base 2. You can pick any of them. You can pick any of them. You can pick any of them. P is equals to this. P is also equals to this. But since we said P is equals to this from our first solving, so we are going to pick this. We are going to pick P is equals to 4 to the power of log x to base 2. And we know our P is equals to 2, right? Our P is equals to 2. We can say 2 is equals to 4 to the power of log of x to base 2. So 2 is equals to 4 to the power of log x to base 2. From here, we can look for the value of what? Of x. So let's see how we can do that. So since we got to this, we can say 2 is equals to 4 to the power of log x to 2, right? We can write this to be 2 is equals to 2 to the power of 2 log x to base 2. If we should bring this to the top, we can have 2 is equals to 2 log x squared to base 2. So this and this will cancel up. So what are we left with? We are left with log of x squared to base 2 is equals to 1, because this one is carrying a power of 1. So we are now having this. From here, we can say our x squared is equals to 2 to the power of 1. 2 to the power of 1. This one is from a basic rule. If you are having a or if you are having log a to c is equals to b, our a is also equals to b to the power of what? Sorry, c to the power of what? C to the power of b. If you are having log a to bc is equals to log a to bc is equals to b. If we want to look for a is equals to c to the power of b. So that is what we applied here. So we're now having our x squared is equals to 2 to the power of 1. So if you are looking for x, so your x is also the square root of what? Of 2. So this is the value for x. Recall I said we are going to plug the value of x into our question to see whether the value of x is correct. So let's plug it into the question. Okay, since this is our question, we are having x to the power of 3 or to the power of 4 to base 2 plus 4 to the power of log x to base 2 is equals to 10. Then we say our x is equals to root of what? Of 2. And we said, well, let's try what it's going to give us. Let's plug in the value of x into this question to see whether it's going to be equals to 10. So if we should do that, let's work at this, the whole of this first. We can rewrite the whole of this to be x to the power of 3 log of 2 to base 2 to the power of 2 to base what? To base 2, because if we say 4 2 to the power of what? 2, right? Plus 4 to the power of log what? Log x to base 2 is equals to 10. We can simply bring this one to the back. We can say x to the power of 3 times 2 log 2 to base 2 plus 4 log 2x is equals to 10, right? So this and this can go. So we're now having x to the power of 3 or to 2 to the power of 2 plus log x to base 2 is equals to what? To 10. And we said our x is equals to root of what? Root of 2. So we can say root of 2. We can say root of 2 to the power of what? Of 3 or to the power of 2 plus log, sorry, we are having 4 here. 4 to log root of 2 or to base 2 is equals to 10. Right? Okay, recall I said if I'm having a to the power of m or to the power of n is also equals to a to the power of m times n. And I also said a to the power of m times n is also equals to a to the power of n or to the power of what? Of m, or to the power of n. So if we should apply this rule here, we can simply write the whole of this to be 2 or square or to the power of 3 plus 4. We are having 4 log. We can write this to be 2 to the power of 1 all over 2 or to base 2 is equals to 10. We should bring this to the back. So this and this will go. So we are having 2. We are now having 2 to the power of 4, 3. Right? Because this is a square. You can cancel off this. You can cancel off this. We are now having 2 to the power of 3 plus 4 times. This one is coming to the back. 4 times 1 all over 2 log 2 to base 2. So this and this can easily strike off, because since they're having both base 2 to base 2 can cancel off, because we say if we're having log 10 to base 10 is equals to 1, log 2 to base 2 is also equals to 1. So we're now having 2 to the power of 3, and 2 to the power of 3 is going to give us what? 8. 8 plus. We are now having 4. We are now having 4. Let me write it here. We are now having 4 to the power of 1 all over 2, which is also equals to the square root of what? Of 4. The square root of 4, because we are saying 4 to the power of what? Half 1 all over 2. And 4 to the power of 1 all over 2 is also equal to the square root of 4. And the square root of 4 is going to give us what? It's going to give us 2. We are now having 8 plus what? Plus 2 to the power of what? Of 1. Because we said log 2 to base 2 is going to give us 1, right? 8 plus 2 to the power of 1 is equals to 10. And if we should add both sides together, so this is 10, sorry, equals to 10. And if we should add both together, we are going to have 10 is equals to 10. So the value of x is correct. So if you find this video interesting, please click on the top sum button. And if you have not subscribed, kindly do well to subscribe so that you get notified, and hit on the notification button so that you get notified anytime I drop videos on mathematics. Bye for now, and see you in our subsequent video. Jesus loves you.